Moving right along with problem 16. This one asks us to compute 1 plus I over square root of 2 to the 4,444,444 power. This is a hard question unless you know about polar form of complex number. So if I draw the complex plane, this number, which I can rewrite as root 2 over 2 plus root 2 over 2i. Right, it's right here in the complex plane. Its distance from the origin is 1, and angle is 45 degrees. It's better known as the 8th root of unity, one of the 8th roots of unity, I guess. So the fact that we can know about this is that this number raised to the 8th power equals 1. So even though the exponent is huge, we can throw out any multiples of 8. In particular, 1,000 is a multiple of 8. In particular, 400 is a multiple of 8. In particular, 40 is a multiple of 8. So I really only have to raise to the 4th power, and that's 1, 2, 3, 4. So the answer is -1, and that's B. Pretty neat when you know how to do it, right? If you don't, that might not have made a lot of sense. One car goes around a track in 30 seconds. The second car goes around the same track in 50 seconds. How long will it take the faster car to gain 1 lap? Okay, so how long until they get lapped, essentially? I feel like I just want to do this one experimentally. So after 75 seconds, the fast car will have gone 2.5 laps, and the slow car will have gone 1.5 lap. So it looks like answer A is correct without really having to think about it too hard. The fraction 1/4 is expanded in base B, where B is an integer with B bigger than 2. The expansion need not terminate. If only the digits 0 and 1 are required, what are the possible values of B? Okay, need not terminate. I haven't thought about expanding. Okay, so I haven't thought about it. I don't want to call it decimal expansion because it's not base 10. Anyway, I haven't thought about expanding into decimals in different bases for a while. So let me come back to this one in a second. Let me keep that in the back of my mind. Moving on to problem 19. We have a polynomial, cubic polynomial, x cubed plus ax squared plus bx plus c. And this has 3 distinct real roots. Two of them are 1 and 2. Which of the following statements must be true? Okay. And the third one we don't know, but because the leading coefficient is 1, I know that I can factor it this way. I guess I can start to multiply this out, but I have some options here. C equals 2a plus 6. Well, we're not quite sure. What I can say is that C for sure equals negative 2r, whatever that third root is. A equals -3 minus r. And then x is going to be 3r plus 2. B is going to be 3r, 2 plus 3r. Alright, so I have those three facts. Now let's see which one of these is possibly true. C equals 2a plus 6. So negative r is a plus 3. So negative 2r is 2a plus 6. C equals to 2a plus 6 is true, so A is the answer. And I don't have to read the other choices. That's good. Let's take a look at problem 20. How many integers satisfy both of the following inequalities? So I want to have x times x minus 6 times x minus 8 to be bigger than 0. I'll look at this one first. It's a nicely factored polynomial. We have an 8, we have 6, and we have a 0 as the three roots. It's a cubic with a positive leading term. So it'll look like this. So we already have possible values for x that are integers are 0 up to 6 or bigger than 8. The other inequality looks like x minus 5 over x squared minus 3x plus 5 less than 0. If I try to factor this denominator, I will find no roots. 3 squared minus 20 is a negative number, so this quadratic is always positive. So this is a rational function. It has a 0 when x is 5. Its end behavior is it approaches 0 and it's positive when x is bigger than 5. And it approaches 0 and it's negative when x is less than 5. So in total, the graph looks something like this. This was less than or equal to, so x should be, so for this polynomial to be negative, x should be less than or equal to 5, and an integer. So overall, combining these two, x has to be between 0 and 5. There are 6 integers between 0 and 5. The possible answer choices are 1, 2, 3, 4, or none of these. So the answer is E, none of these. Okay, so let me think about bases. So if I want to expand in base B, right, what I'm thinking about it in base 2 is going to be 0 halves plus 1 over 2 squared, and we're done. In base 4, it's going to be 1 over 4, and we're done. In base 5, it's going to be 1/5 plus how many 25ths do we need? So this is a weird question. plus 1/25th. And then 1/20th minus 1/25th is going to be I think it's going to repeat. Let's try this again. Okay, so 10 in base 5 is 1, so I have 1, 4. Yeah. 10 minus 4 is 1, so it will repeat. So bases 2, 4, and 5 definitely only use zeros and ones, and then looking at the options, B is a possible answer. C and D are both missing the 2, and E says there's no possible values, so the answer has to be B. And I don't need to check my division using 3, 6, or 7.